Hey everybody, welcome back to part 4 of our Minecraft Tower Defense coding tutorial. In our last lesson, we recruited our old Minecraft pal Steve to help defend our house from the approaching mobs. In today's lesson, we're going to arm him with a physics-based bow and arrow that he can use to defend his house from a distance. If you've just discovered this tutorial series, you should probably go back and start at part 1. The link is right up there in the corner. But if you do want to start coding from right here, you can load a Scratch catch-up file that has all the code that we did in parts 1, 2, and 3. The link is right down below in the description. Make sure to like and subscribe to Chromeworks Technology for more amazing Scratch tutorials. Now let's grab a bow. We're hunting creepers. Hey, and welcome back to part 4 of our Minecraft Tower Defense coding tutorial. You might recall that back in part 3, we started to set up our defensive systems here. So we've got walls set up here. When we click on this green block here, it will allow us to set up walls, assuming we have enough stone collected here. We can set walls up here like this, and then we can toggle over to a defensive mode here that will let us place archers, thieves, on top of any of these items or on the at ground level if we want to as well. So in this episode, we're going to be arming our Steve with arrows and letting those arrows fly, and it turns out to be quite a bit more complicated than you think, largely because all these guys are moving in only 2 dimensions here, or actually 1 dimension really. They're just moving horizontally across the screen unless they climb across a wall or blow it up later on. So, but you can see here that these zombies are starting to stack up here. They're actually piling up against the wall here. Now if I shoot an arrow into one of them, Scratch is going to think I've collided with all of them and kill all the zombies. That is no good. We only want 1 zombie hit by each arrow. And to do that, we're going to do some fairly fancy trickery here with the list variables. So that's one of the things we're going to be learning about today, is how to get clones to tell each other apart using list variables. So we'll get into that in a little bit. Now, the file you're working on might be missing 1 sprite here, the targeting reticle, which we added fairly late in the development process. So if you don't have a targeting reticle, I'm trying to get this on the screen here, but it just won't pick up. Let me move it to the middle here. We'll just send it to 0, 0. There we go. So if you don't have a targeting reticle sprite like this on your screen or in your file, you might have grabbed the starter file before we had a chance to update it. So go ahead and grab the original starter file for Minecraft Tower Defense, drag this reticle into your backpack, and then drag it back out into your game again. And that way you'll have access to that graphic. If you're not feeling enthusiastic about doing that, you can also just design your own targeting reticle. You can see it's a fairly simple graphic here. You just need a hollow spot in the middle to show where you're aiming at. All right, so let's start coding this. So this is central to our shooting. It's telling us where we're aiming at. So let's go ahead and we're going to slave this to our cursors so that the reticle is following our cursor around. We're going to grab a green flag. And the first thing we're going to do is set up 1 variable here. We've got a variable called shooting mode active. At the beginning, by default, that is at 0. So we're going to be placing things rather than firing at the beginning. All right, let's go grab a forever here. And we're going to say if shooting mode active is equal to 1. So let's grab that variable after we put the equal sign down. Shooting mode active is equal to 1. I've got a second sprite here called shooting mode active that has capital letters. I think that got put there by accident. So you'll probably want to, if you do see that one on your screen, let's just delete it because we only need the 1 variable. If shooting mode active equals 1, then we're just going to go to mouse pointer. So that's going to slave our cursor to the mouse pointer, which is right up here at the top. Now it's not going to happen right away because our shooting mode is actually 0, but let's set it to 1 here just temporarily. And you'll see that our cursor is following my own mouse cursor around. Beautiful. All right, now we don't want that cursor to be active when we're underground, so we're going to set up an if statement down here below. Actually, this is an if-else statement, by the way. Let's modify that right now before I get too deep into this. If shooting mode active is equal to 1, go to mouse pointer. And we have an extra if statement here, which will pop underneath. And we're going to say if our Y position is less than 46, which means, let's grab a Y coordinate here, which means that our cursor is underground where we're not allowed to aim, then we're going to set Y to 46. So let's go set Y to 46. And so that will basically stop our cursor from going underground. Let's have a look at that. And you can see when I move it too far down, it just settles on 46 here and won't go any higher than that. Okay, beautiful. And so that'll let us know that we're not allowed to shoot while we're underground. Okay, now this may be hidden. So we're outside this if statement down below. We'll go to our looks commands here and do a show. So right underneath the if statement, but still inside this first block of the if else, we're going to show, and we're going to go to front layer as well. Go to front layer. All right, that's going to make sure that our targeting reticle is always at the front. And if we're not in shooting mode, then we're just going to hide it. So that's going to allow us to toggle back and forth. Okay, so how do we go back and forth between those two different modes? I described it before. I said we were going to be using the space key. So let's grab a when space key pressed, and we'll do an if else in here as well. If shooting mode active is equal to 1, so let's go to our variables. Shooting mode active. Oh, we need an equal sign as well, but let's grab this first. Oh, we have an equal sign. It's equal to 1. Then we're going to set shooting mode active to 0. Otherwise, we're going to set it to, sorry, I tried to duplicate that. We're going to set that to 1. So this will basically toggle back and forth. If it's on, it'll turn it off, and if it's off, it'll turn it on. And that should, yeah. So when we hit the space key, the targeting reticle disappears. When we don't, sorry, when we hit the space key again, it reappears. It won't go underground. Everything's looking good here. So that's actually all we have to code inside the targeting reticle. Let's go up to the top here and make sure we're setting the default mode back to 0 so that it starts turned off rather than turned on. Okay, so now we're going to move over to our archer bow. Let's have a look at the costumes here. So there's a default costume here that's called Minecraft Bow GIF 24. That's kind of a big mouthful, but it's basically a bow that doesn't have an arrow knocked in it yet, and that's our default bow that's going to appear here. We're going to have to rotate it around so that it faces in the same direction as our Steve when we put him down, and then we're basically going to slave this bow to the current location of Steve, and then we're going to run him through this animation where he pulls his bow back and then fires, and the arrow flies out. Okay, so in a second we're going to start coding our arrows. Firstly, though, I want to kind of give you an overview of what we're doing here with the lists. So I mentioned that we're using lists to keep track of a lot of complex interactions here with the clones so that we know which clone is shooting from where and what it's hitting. So you've already seen this list here called Archer Indexes. And this one is keeping track basically of the number of archers on the list. So we've got, when our first archer gets created, he'll have a 1 here on this list. The second one will have a 2, and that'll be the identification number of each of these clones. And so as they die, they'll be removed from this list, and the computer will know they're no longer active. Now I've also got a list here called ArrowQ, and another one called ArrowQX and one called ArrowQY. And so these are keeping track of what the X and Y coordinates are of each arrow that's fired. So they'll all be put into a queue here. Basically, as they shoot, their X and Y coordinates are going to get listed here. And then the computer will process where each arrow is going to go based on its initial starting position. It's going to work that through this queue, placing arrows, and then start moving them. If the arrow hits something, then it will be noted here in this other list called arrow hits X, and that will keep track of the X coordinate where the arrow struck something. Now there's only one possible Y coordinate for each X coordinate. There's only one spot where a bad guy can be. If there's a wall here, for example, if there's a wall on the screen, then all the bad guys are going to climb up and be on top of that wall. They'll always be at the same Y coordinate, no matter where they are on the screen. So we don't have to keep track of Y. We're just keeping track of X coordinates for where the arrows hit, because there's only one potential Y coordinate where each bad guy can be. That's a little bit complicated, but it'll make more sense as we go along here. Okay, so the first thing we're going to do here is just clear off all of these lists so we can, at the beginning of the game, so we can start with a fresh palette here. So let's go down to our list variables. We've got this block here that says delete all of, and we're going to delete those 3 lists that I mentioned here. So let's grab this 3 times. So we're going to delete arrow hits X, and then arrow QX and arrow QY. So that's going to clear off those lists. We're going to hide our bow until it becomes relevant here. So let's go hide it. All right. So the clones of this bow are being made over in the Archer. We actually had a create clone command over here in the Archer. Right here towards the bottom, you can see we created a clone of the Archer, but we also created a clone of the bow at the same time. And while we were doing that, we were keeping track of the X and the Y location where we placed the Archer with this variable here called new Archer X and new Archer Y. We're going to be using that now to place our bow on top of each new Archer who's placed. So let's go back to the bow here. Okay, so when we started the clone here with this bow, let's go grab when I started the clone from our control blocks. The first thing we're going to want to do is spin this guy around. He's set up in a at an angle right now. That's his default graphic, but we actually want him facing up, down. And we can do that by spinning him 135 degrees. So I'm just going to go turn to the right 135 degrees. And then we'll just position him so that he's turned in the right direction when he's created here. Now we have a variable here called my Archer index. We're going to set that right now. Set my Archer index. So that is basically which Archer do I belong to. That's what my Archer index is. That's a local variable. Let's have a look at that. Yeah, you can tell it's a local variable because there's a colon there, Archer bow colon my Archer index. So that's a local variable, and that will belong to this specific instance of the bow. So my Archer index, we're going to set that to equal the new Archer index, the number that was just assigned to the Archer that created it. So new Archer index. Okay, so this will make sure that our bow has the same index number as the Archer that it just created it, because we set this new Archer index over in our Archer when we created it. Okay, now we're going to go to the location of that Archer. We just stored that new Archer's location in a variable called new Archer X and new Archer Y. So we're going to place those down there, new Archer X and new Archer Y. So this will mean that these guys will appear in exactly the spot where the last Archer was created. The new bow will appear in that spot. All right, now our clone, we want to be visible. So let's go to our looks and do a show. Then we're going to grab a forever here. And here's where it's going to be evaluating whether it should shoot or not. So if shooting mode active equals 1, which means we've flipped over into firing mode. So let's go grab an if statement. And now an equal sign from our operators. And we'll go to our variables and we'll grab the one that says shooting mode active. So if we're in shooting mode, then we're going to slave our bows to the mouse pointer. So let's go to, or point towards mouse pointer. All right, and that will keep it pointed in the right direction. But again, we have to offset it because its default isn't straight up and down. So we're going to have to go turn 135 degrees. And yeah, so now every time we place one of these guys, let's give that a try right now. So I believe I have enough gold to place one archer. So let's try placing one archer here. Whoop, wrong mode. And you can see that his bow is there. It's behind the archer right now. Let's go to shooting mode. And you'll see that now our bow, while it's in the wrong place, it is attached to our guy. And it's pointing in the proper direction. When I point to the right, the bow's to the right, etc. Okay, you can see the zombies aren't killing us yet. We haven't implemented that code. They're just ignoring us. Okay, so far so good. Now, let's do another if statement down below. So this little block of code here, the next one we're going to do is going to determine whether the archer that's attached to this bow is still alive. When this archer gets killed, his bow has to be deleted with him. So we're going to look at the list called archer indexes and see if my archer index, the number that belongs to my bow, is still represented on that list or not. If it's not on the list, it's going to delete itself. So let me show you how that works. We're going to go to our operators. We're going to grab a not, and inside there we're going to do we're going to look at the contents of that list. So we're going to go down to our list variables. So we're going to grab this darker reddish brown block called something contains a thing. It's a third from the bottom of our list here. So we're looking inside our archer indexes to see if it contains that number that matches up with my bow and my archer number. So that is my archer index. Let's go back to there. And we'll grab my archer index and plunk it right here. Okay, so that's all going into the not. So if the list of archer indexes, archers alive, contains the number of my bow, then my bow will remain alive. If it doesn't, though, then we're going to delete this clone. So as soon as that archer that's holding that bow is no longer alive, it's going to automatically delete that clone. Okay, one other thing here, you notice that the bow was behind the archer, and we're going to do something a little more sophisticated here with an if-else statement where it's going to be in front of the archer if he's facing in one direction and behind him if he's facing in a different direction. That'll create more of a sort of three-dimensional look. So if direction is less than 0, if he's facing to the left, so let's go grab a less than sign. And we're going to grab a direction from our blue motion blocks. If the direction we're facing in is less than 0, which means we're facing to the left at the negative number, then we're going to go to the back layer. Let's go to our looks commands. We'll grab a command here that says go to front and change it to go to back. And then the else will be go to front. And this way, depending on where we're facing, the bow will either be at the front or at the back here. Let's give that a try. Build an archer. Get into shooting mode. And you can see when I'm facing this way, oh, it's actually the opposite. So when I'm facing to the right, the bow is on the left. When I'm facing to the left, the bow is in the front. Okay, there we go. Beautiful. Okay, this next block of code we're working on is going to control the animation of the bow. So pulling the bow back and making it look like it's ready to shoot an arrow. So we need another when I started the clone here. And we're going to put a forever and attach that. All right, so the first thing we're going to do is, it is an if-else statement here. So let's grab an if-else statement. So the first thing we're going to be checking for is, am I shooting? Now there's three things we need to check for. We're checking, am I clicking my mouse? Is my mouse positioned above ground level? and am I in shooting mode? If all three of those things are true, then we're going to be able to start shooting. So we need two and statements here to both attach together. All right, so the first thing we're checking for, as I said, is our mouse down? Are we clicking? And are we above ground level? So is our mouse Y, the position of our mouse, is it above 45, which is where ground level starts? So if our mouse Y is greater than 45, and are we in shooting mode? So we're going to grab an equal sign here. And we're going to say shooting mode active is equal to 1. All right, so if all the conditions have been met that will allow us to start shooting, then we're going to start flipping through the costumes of our bow here. So let's grab a next costume. And the animation rate here is going to be 0.1 second delay. So that's the delay in between changes in animation. All right, so it's going to keep switching costumes until the bow is fully extended. So let's go. We're going to put an if. Yeah, we're going to grab an if statement down here and put it underneath the weight. And we're going to say if costume number is equal to 5. Go to our looks commands here, grab a costume number. If our costume number is equal to 5, and if you look at your costumes here, that costume number 5 is the one where our bow is pulled out to its maximum extension before we start shooting again. So this is the spot where we're actually ready to let loose with our arrow, and then the bow will return back to its normal state again without a arrow in it. Okay, so if our costume number equals 5, which means we've pulled it all the way, then we're going to wait until we've let go of our mouse button to fire. So we click to pull back our arrow, and if we successfully pulled back our arrow all the way for 5 frames, then our arrow will be ready to go, and as soon as we let go, it'll fire. But if we let go of our mouse before we get to 5, then it's going to ignore all of this, and the bow will just reset itself. So if costume number is equal to 5, we're going to wait here. So let's go to our control blocks. We'll grab a wait. Oh, actually, sorry, that's an event block. We're going to grab a... No, I think it is. Sorry, it is a control block. We're going to grab a wait until. We're going to wait until we've let go of our mouse here. So we need a not. And now we need mouse down. So wait until we let go of our mouse. And then we're going to continue with the changes of costume here until the costume number is equal to 8. So let's go grab a repeat until costume number is equal to 8. Go to our looks. Costume number is equal to 8. So now it's just going to continue with the animation till the animation is fully run, which means we pulled back our bow and now it's flipped back to the start position again. And we're going to keep going next costume through each of those changes until we get to number 8. And once we've reached 8, we know we've successfully fired. So we're going to play a sound here. So let's go to our sounds command. We're going to play this sound called bow shot. There we go. And that is going to go below the repeat until. Now, we want to, at this point, record on our list our arrow QX and our arrow QY. We're going to record where did that arrow come from. So we're going to start to keep track of where we shot arrows from, basically. So let's go to our list variables again. We're going to add to our list. So we're going to grab this one here that says add thing to list. We're putting that right below the sound. Let's do that twice. So we're going to add our X position to the first list and our Y position to the second list. This is going to say arrow QX, and this is going to say arrow QY. So we're basically adding the current position of our archer that just fired a bow to that arrow queue, and then the arrow will process that and know to launch an arrow from that location later on. All right, we're going to add a wait 0 seconds. Now, why do we do that? 0 seconds seems like a strange amount to wait. All that does is sometimes you've got stuff happening simultaneously in other sprites, and you want to make sure that it executes in a certain order. By adding a wait 0 seconds, we're saying that whatever happens next here will happen after what happens, I assume, in the arrow here. So the arrow will get to do its thing first before this script continues. Basically, we're just changing the order around by adding this wait command. Even though it's not zero isn't technically a number that we have to wait, it's still enough to push this down in the order of things that happen here so that it happens next on the list. All right, so after that happens, we're going to go back to next costume. So we'll go to our looks commands, add a next costume, and that will return our arrow back to the very first position, which is this one here where there's no arrow in the bow. All right. Now, if we let go of this before we reach number 5, then we're gonna move our bow back to its starting position before we fire an arrow. And so that's what this else statement is all about. Basically, if we haven't gotten to the point where we're ready to fire an arrow, then it's gonna abort the arrow creation process. Okay, so let's go switch costume. Let's grab a switch costume too, and we want to go backwards now. So we're going to grab a minus sign from our operators, and we're going to switch costume to costume number -1. Let's go grab a costume number from our looks. Costume number -1. So that'll go backwards. So in this else condition, which is we're not firing an arrow, if we've already moved past the point where we fired an arrow, meaning our costume is greater than 5, instead of moving backwards, we're just going to run right back to the first frame of animation. So I'm going to put an if statement in here, right below switch costume, that says if costume number is greater than 5. And that's going to circumvent all of this, the rest of this stuff, and just return our arrow. So let's go costume number is greater than 5. So if we've already advanced to the point where we're shooting, and now suddenly we've let go of the mouse button or moved our cursor down, then it's going to switch automatically down to switch costume. Let's go to our looks. Switch costume 2, and we're going to grab that first one, Minecraft Bow GIF 24, which is actually the first blank costume here with no arrow in it. Okay, so let me show you what that looks like. We're still not firing arrows, but I think we should be able to create that sound effect. So I'm going to create my first archer here. He has a bow on top of him. Let's get to shooting mode here. And we'll shoot to the left here so you can see this a little more clearly. Let me zoom my screen. So when I hold down my bow, you can see that he pulls his bow back, and then it moves forward and makes a shooting sound. Beautiful. Now if my mouse is down here below this, he doesn't shoot because our conditions for shooting haven't been fulfilled. You see that if I let go of the bow before I get a chance to fully shoot, it'll just return itself back to its start position again. So this functions very much like the typical Minecraft bow in the actual Minecraft game. You can see that if we try to fire too quickly, it will just abort, and if we hold it down, it will knock the arrow and get ready to go and wait for you to release, and then it'll fire that arrow. Okay, that's working beautifully now. Okay, and I think we are done with the bow for now. I just wanted to show you what was happening on those lists though. So let's go back to our list variables and let's have a look at our arrow cue, X and Y. And you can see that every time an arrow was fired here, the X and Y coordinates of the arrow were added to that list. Now they're not being deleted from the list, so it just keeps adding them over and over again. So the location where we place that guy is an X of 72 and a Y of 72 and an X of minus 104. And so it's just that same arrow shooting over and over and over again. What's actually going to happen here is as we create these arrows, it's going to delete them from this list. It's going to deal with the arrow, place one at this coordinate, and then it'll delete it from the list so that Scratch knows that that arrow has been fired, and it'll work its way through the queue until this list is empty, and then it'll be done shooting arrows. So, okay, this is working nicely now. Now we get to the fun part where we're actually shooting arrows. Okay, so here we are inside our arrow sprite. We're ready to start coding the movement of the arrow. Now, when we fired our bow, we didn't actually create a clone of an arrow. We simply took the location of the arrow that was going to be fired and saved it into a list with its X and Y coordinates called arrow QX and arrow QY. And that's going to create a big long list of all the different archers on the screen and where they're firing from. So we're going to start processing that cue and basically placing an arrow down in each location that's been noticed in that list. Let's start with the green flag here. So we're going to go to front for starters here because, of course, we want the arrows to be in front of everything else. Now they're quite large, these arrow graphics, so we're going to shrink. Let me show you what they look like here. And you can see it on the screen there. It's a little bit bigger than we actually. So this is shrunk down to 13%, which is the size that we're going to want. If it was at 100%, you can see that it's quite large on the screen there. So we definitely do want to shrink it down. All right, so let's change it to 13 manually here. And in the code, we're going to change that to 13% as well. So set size. In our looks commands here, we'll set size to 13. There we go. We're going to hide our master arrow, and the clone will of course be visible later. We're going to set its ghost effect, its transparency to 0. All right, so even though it's hidden, we're affecting its transparency here as well. Okay, so all this main queue is going to do is just constantly keep looking at this arrow queue, checking to see if any new arrows have been fired. So we're going to do a custom block for that. Let's go over to our custom blocks, and we'll create a new block by clicking on the Make a Block button here. And we're going to call this one Handle Arrow Q. Q is spelled Q-U-E-U-E, in case you wanted a little English lesson there. Now it's very, very important. There's a little button check box at the bottom here that says run without screen refresh. We do have to click this. We usually don't, and it can sometimes mess with our program if we do. But in this case, we want it to keep going through this list all in the same frame. So it's going to process all of the stuff all in one gigantic series of calculations. So that's why we want to run this without screen refresh. There we go. And that'll kind of turbocharge the way that this handles this arrow queue. All right, so I have a new block now called Handle Arrow Queue. I'm going to put it inside my forever loop. And so basically this is just going to keep spinning around in a circle, checking for arrows and creating clones of them where necessary. And then after it creates a clone, it's going to delete it from the list. So let's go ahead and define how that works. We're going to do a repeat until in here. Let's go to our control blocks. We'll grab a repeat until block. We're going to repeat until the arrow queue is empty. So we don't need the X and the Y here. We'll just find the X. So we're going to go to our list variables, and we're going to go length of, so we're going to look at the length of that first list, length of arrow QX. And we're going to wait till it's empty, so until the length of it is 0. So we'll go equal to 0. I'm going to move that down so it gets out of our way here. So keep doing this until the list is empty, basically. And then when the list is empty, it's just going to keep spinning around here and doing nothing until the next time you fire an arrow. Okay, so the first thing we want to do is we want our clone to appear on top of the spot where our first arrow is. So we're going to use a go to XY command, go to an XY coordinate. And we're going to want to look at the first X coordinate on the list and the first Y coordinate on the list. So we're just going to go to our variables here, grab our list variables here, and there's one here called item 1. So we want to look at the first item on the list of X coordinates and the first item on the list of Y coordinates. And so we're going to place it in the spot that was saved where the last, where the arrow shot from, or where the bow actually recorded the shot. Then once we've moved to that location, we can go ahead and create a clone of myself. And then we're going to clear that item off the list. We're going to delete. So let's go to our list variables again. We'll grab the item here that says delete item 1 of our X values and item 1 of our Y values. Whoops. So we've created a list of where all the arrows are going. Then we're going to go to the first item on the list. We're going to place ourselves on that list, and then we're going to delete that item from the list so that the next time we come around, we're going to grab the second item, which is now the first item, place that down, delete that item from the list, and keep going down this list until the list is empty, basically. Okay, so we created a whole bunch of clones, one for each one of the Steves we have down on the screen here, and now we're going to start those arrows moving. Now this involves trigonometry, the science of triangles, which I've talked a couple of times. It's actually the math of triangles rather than the science of triangles. I've talked about this in previous tutorials as well. This is some fairly advanced level math here that has to do with something called vectors, which is basically what angle is something moving and what direction and speed is it moving. So if I'm moving at this angle, at this speed, where will I be 1 second from now? And if I'm moving at this angle, at this speed, where will I be half a second from now? That kind of stuff. So we're taking speed and direction and calculating what position we're gonna be in. That turns out to be fairly complicated. It's trigonometry, which involves these math functions called cosines and sines, and don't necessarily have to understand it all in order to use this in coding. And this is something that I keep hammering home. Most of the kids who are watching these tutorials are 10, 11, 12 years old, and we're not expecting you to understand this complex trigonometry right here. But that doesn't mean you can't use it in coding. And so this is one of the powerful things about coding, is you can take other people's ideas and use them to build on your own stuff. So it's like memorizing a recipe for something. You don't necessarily have to know the chemistry of what's happening when you cook an egg, as long as you know, grab an egg and put it on a frying pan, and nature does the rest of it, right? So we're going to be using this stuff, and I'm not necessarily going to be explaining all of it as we go along here. I'll try to put it into the simplest terms that I can so you have a general sense of how it's going. But if you're interested in learning more about trigonometry, I would really suggest you take some tutorials at Khan Academy or another great math site and learn a bit more about this yourself. But if you end up taking advanced math in the later years in high school, you're going to learn all this stuff as well. Okay, so when I start as a clone, let's go to our control blocks, grab a when I start as a clone. So when our arrows are actually created on the screen, we want them to be visible. Let's go to our looks. We'll go show. We're going to have them point towards our mouse pointer. So for when they start moving, they're going to be pointing in the direction that our mouse cursor is is facing, and we actually have this little cursor on the screen here that's going to let the player know exactly where that arrow is being pointed towards. All right, now the arrow is going to start at the end of the bow rather than at the beginning end, so that's about 20 pixels away from the center of its spot. So the first thing we're going to do is move it 20 steps, which is 20 pixels, so that it doesn't start in his middle. It will start at the end of his bow, basically. Perfect. All right, so we've got a bunch of variables here that have to do with where the arrow is at any given point. There's a variable here called position X and position Y. That's the X, Y coordinates of where the arrow is right now. And then we've also got speed X and speed Y. So speed X is how fast is it moving to the left, right, and how fast is it moving up, down is speed Y, right? So a lot of this math is figuring out if we have a speed and we're moving at a certain angle, how much of our speed is horizontal and how much of our speed is vertical. For example, if I'm shooting straight up in the air, all of my speed is horizontal and I won't move left and right at all. If I'm shooting directly to the left, like at a 90-degree angle to the left, most of my speed is going to be horizontal, except gravity is going to start pulling my arrow down as well. So there's going to be a little bit of vertical speed no matter what happens. All right, hope that makes sense to you guys. So let's go, we'll start by setting the X position. So let's go set some variables here. So we're going to set position X and position Y. And we're just going to set that to our current X position and our current Y position, which we can find in our blue motion blocks, X position and Y position. So at the very start, before we get into our loop, we're setting our initial X and Y position, and we're going to set our initial speed as well. So let's go set speed X, set speed X, and set speed Y. Now here's where that trigonometry comes to it. The speed X is the amount of our motion that's going to be dedicated to moving left and right, and that depends on the angle that our bow is facing. So we're going to use these functions here in our operators. If you go to the bottom green operator that says abs or absolute value, we can change that to sine, which is sin, like sin, which is the fifth one down here. We're also going to need one called cosine, which is COS, which is right below sin. So our X speed is going to be the sine of our current direction times 10. So let's go grab our direction. I'll explain this in a second. Sine of direction and cosine of direction is going to be our Y. And we're going to multiply this by 10. Let's grab a times here. We'll pop that in there. Sine of direction, and then multiply all that by 10. Okay, so we've got our two commands here. Let me give you a quick look at what these do. So depending on the direction, so again, I'm going to grab this direction slider here and I'm going to move it to the up position. So let's assume I'm shooting my arrow straight up in the air. So it's pointed in direction 0, which is straight up in the air. So, I put a 101 there instead of a 10. Okay. All right, so my sine is going to control the X speed, which is a horizontal speed. So if I'm facing straight up in the air, the number that returns is a very small number, 0.37. But my direction Y, which is my vertical direction, speed is going to be almost 10 here. So you can see that both these numbers actually, I believe they add up to 1, basically. So most of my speed is y speed, up, down speed, kind of pointing up. What if I'm pointing at a 45-degree angle? Now let's look at the new numbers here. This one is 8, and this one is 5. So that's actually not a perfect 45-degree angle. Let's actually change that angle to exactly 45 and see what kind of numbers it yields us. So 45 is halfway between straight up and straight to the right, right? So this is 7.07 and 7.07. So because the two forces are equally balanced, we get the same number here for both of them. And they don't add up to 1. I was wrong about that. All right, so you can see, and when we move over to the right here to a 90-degree angle, then the x speed is 10. So almost all the speed is going into our x movement. And if we look at our y number, it'll be very, very small, actually minus 0.06 here. So the more horizontal my speed is, the higher this calculation number is going to be. And the more vertical my speed is, the higher this number is going to be. And so we don't need to understand quite how these numbers are derived. We just need to know that this is keeping track of what the angle is and trying to figure out how much of our speed is going into changing our vertical speed, our vertical position, and how much of it is going into changing our horizontal position. There we go. So that's placed in there now. And now we're going to start modifying those numbers as the arrow moves through its flight. So let's go, we'll grab a forever here. Control forever. All right, the first thing we want to do is switch our costume to an arrow. We have two costumes here. One is called Minecraft Arrow and the other one's called Arrow. We're going to be using this one when our arrow flies off our screen. So we are allowed to shoot right off the screen here in this case, in this game. And when our arrow does fly off the screen, it's still going to exist. It's going to be moving through this virtual space above the screen until it finally falls down again. So we're going to keep track of that by later on by changing our arrow to a different shape, and that's going to keep track of where off the screen our arrow is flying. Okay, so let's switch costume to an arrow, just in case we switched it to something else. Or Minecraft Arrow, sorry, which is the proper arrow. Now, we're going to keep changing our position, our position X, our position Y, and our speed Y here as we're going along here. So let's go to our variables. We'll change some variables. We're going to start by changing our position X by our speed. So we set our basic speed here. So let's go grab one that says speed X. So whatever our speed is, that's the amount of our movement that's going to change in our position. So we're going to change our position by speed. We're going to change our position Y by our speed Y. And then we're going to reduce our speed because we're going to reduce our Y speed because our arrow is falling. This is where the gravity comes in. So we're going to change speed Y by minus 0.2. There we go. And so these are all variables. Nothing's actually changed our arrow yet. So let's go ahead and we'll grab a go to block here. Go to XY. And we'll dump the output of those variables, the new position X and the new position Y, into here. So that will update its position after we've performed this math here. We've changed our position based on our speed in both directions. All right, and so that's the basic physics of it. There's some more things we're going to add in a second here, but I think we can try this out at this point here. So let's go ahead and start the game. And let's place down our first archer. And let's try getting into shooting mode and shooting an arrow here. And there we go. There's our arrow flying based on the physics. Nice. Now we can't actually hit anyone yet. There's some problems as well. You can see that our arrow stays facing upwards in the air, which is no good. We're going to want it to point downwards after it gets to the top of its peak. And you can see when I try to shoot it off the screen, it sticks to the top of the screen basically. And that's why we're going to be changing to that other shape. All right, anyway, this is working quite nicely. Now we just need to add a few little if statements here that will change the behavior of this arrow a little bit here. Okay, the first step is we're going to determine if we've hit anything. So let's grab an if statement here, control. So every frame here, we're going to be checking to see if our arrow hit an enemy. So the three kinds of enemies we have in the game here are zombies, creepers, and endermen. So we need an or statement here that contains all three of these guys. Let's grab an or. And another or, and we're just going to we're going to do a bunch of touching, sensing blocks here. So touching. So if I'm touching a zombie or a creeper or an enderman, where's my enderman gone? There he is. So if I'm touching a bad guy, now we're not going to kill these guys right away. As I said before, we're going to use a list to keep track of who's killed here so that each arrow can only kill one guy or do damage to one guy. So let's go down to our list variables. We're going to grab the one here that says add an item to the list. So we're going to add the X position of our arrow. So if it hits, we're going to keep track of where that arrow hit, what the X position of it was, and we're going to put it onto a list here called arrow hits X. So all of those hits are going to get kept track of, and then we're going to process them all later on. Each of our characters is going to basically well, the first guy to get touched will determine that it got hit by looking at its arrow hit X and seeing that it's at the same position, and then it'll delete itself from the list so that the next guy can't get hit by the same arrow. That's kind of the way this is going to work. All right, so after we add our X position to that list, we're changing the size of the arrow by 5. And I'm not quite clear on that. Here's change size by 5. So just at the moment that it hits, we make our arrow a little bit bigger for just a fraction of a second here. And I think that's just a little animation effect to make it look a little cooler. We're going to wait just 0.1 seconds. So that'll kind of reinforce that the arrow hit something. It'll grow in size a little bit. Oh, before we do that wait, we're going to set our ghost effect. So let's go to our looks commands. We're going to set ghost effect to 99. And as you guys who've done my tutorials before will remember, setting ghost effect to 99 means it'll still recognize collisions, but it'll basically be invisible. We're going to wait 0.1 seconds for everything to process, and then we're going to delete the clone. All right. So that's going to deal with killing our clones. We're not going to be able to see that right away. We'll do that in a little bit. Now we need another if statement here that says if our arrow leaves the screen, we're going to delete it out of the game here. So if, and we need a couple of ors here. So we're going to say if we leave the top of the screen or if we leave the left side, the right side, or the bottom, or hit the ground, then our guys are going to disappear. So we need 2 different or statements inside each other. And we're going to grab a greater than and two less thans. All right, so we're going to say if our X position is greater than 238, if we've left the screen on the right-hand side, or if our X position is less than minus 238, which means we've left the screen on the left-hand side, or if our Y position is less than 50, which means we've touched the ground. If any of those three things happen, then we're going to delete the clone. And that's a fairly simple fix here, so let's go ahead and try that out. Place an archer, get into firing mode here, and you can see that if we try to fire off the screen, the arrow just disappears. And if we hit the ground, the arrow will also disappear here. Good. Now I wanted to show you placing multiple archers here, which is now possible. So let's play the game and we'll gather a little bit of gold while we're at it here. Do a bit of mining. There's some gold. All right, I have enough gold now for two of these guys, so let's place them. I'm going to put them on the roof this time. One guy here and one guy here. Get into firing mode, and you can see both guys are adjusting themselves, and when I fire, both guys fire. Beautiful. So everything's working properly. I noticed that our archers are not facing in the right direction. We're going to be fixing that in a little bit, but this is looking good. Okay. Now, as I mentioned, when we go off the top of the screen here, our arrows are still going to be moving. The physics is still going to be checking their location, but the arrows won't be visible. So we're going to put a little marker down that's going to show us where our archers are so we can see them when they come down. So let's go and say if it leaves the top of the screen, so if our Y position is greater than, let's grab a Y position block here. If our Y position is greater than 178, which means it's left the top of the screen, which is at 180, then we're going to point it straight up. We're going to point in direction 90. Oh, actually, so this is just going to change the orientation of the graphic. It's going to make sure that this graphic, which we're switching to, is always pointing straight up, regardless of which direction the arrow is pointed in. And let's switch to that costume now. We're going to go looks, switch to costume arrow rather than Minecraft arrow. And let me show you how that works. So let's go place an archer again. Get into shooting mode and watch when I fire straight up in the air. The arrow is still there. It will finally come down. So that marker is telling us the position of the arrow. Let me shoot straight up. Or almost straight up, and you can see that it eventually drops down to the ground again. So that's just letting us know that our arrow is still there, it still exists, it just hasn't fallen down off the screen yet. Okay, so there's one little bit of housekeeping that we haven't done here, which is our arrows are always facing off to the right, which is no good. We want our arrows to be pointing down when they're firing, to be pointing up when they're going up, and when they come down in their arc, we want them to spin and face the downward direction. Now, this is again an area where there's some really complex math involved. Again, trigonometry. How far along the way from between where we're firing and where the arrow is going to end up are we? And how much tilt should we add the farther it gets along the line here? So this is one of these complex things that I just don't want to teach you. I'm just going to give you the finished block. Now, this stuff was done after we finished coding the original game. I've gone back and updated the starter file for this project. You'll find the link in the description down below. So I want you guys to open up the starter file. If you're starting this tutorial a little after, like if you haven't started this right from the date we released this, you'll probably find that your starter file was already updated with this block. But if you do not have a big complicated block, which I'm going to show you right now, so I want you to look on your sprite and find, there it is, this block that's been left here for you. You can see it uses absolute value, a cosine, square root, and there's just a whole bunch of complicated stuff here. It's checking our speed in all the different directions and figuring out what direction to point the arrow in based on that. Now, as I said, I'm not going to explain how the math works here because it's too complicated. But so what you should do if you don't have one of these on your screen, go to the starter file, go to the arrow sprite, grab this existing block, drop it in your library just like that, and then go back to your project that you're working on. Update your backpack by closing it and opening it up, and your block should be there in your library. The first item now, drag it out to pull it back onto your screen again. We're going to place that down so inside the forever loop, right after switch costume to Minecraft arrows. I'm going to place it right here, and like magic, it's going to correct the placement of our arrows. Let's place an arch down here, and you'll see that now our arrows are arcing beautifully across the screen. When I shoot straight up, watch, it's going to come straight down now. Woo, beautiful. So this looks much more realistic now. You can even fire multiple arrows at once, and they're all being kept track of, and they're all pointing in the same direction. Beautiful. Okay, so we're making good progress. Our arrows are still quite useless, so we're going to add some extra code to our bad guys now to make them be able to take some hits. So we'll get on that right away. Okay, so we're firing arrows quite nicely now, but there's nothing really happening because our guys aren't vulnerable. So we're detecting the collision here in our arrow code. We're detecting that our arrow has touched a mob, but we need those arrows to have an effect on our guys now. So I'm going to go back we'll start with our zombie, and we'll see what we have time to go through here. But so back in my zombie, in one of the main sticks of when I started as a clone here, we've got a little custom block that we created called check for damage. So every frame of animation is going to check and see whether we're touching an arrow and then whether or not we take damage. So whether we take damage or not isn't necessarily dependent on just whether we're touching the arrow, right? As I said before, there could be multiple clones touching the arrow. So which one of them is the one that's going to take damage? We're going to do a little script here that just has each of the zombies check one at a time to see whether they're the one who's colliding with the arrow and whether they're the one who's going to take damage. So let's walk our way through that right now. First of all, we've got a temp variable here. So let's just go set temp to 1. And that will make more sense as we go along here. Now, we're going to go through our list. So when our arrows did hit home and touch a bad guy, they store their X position in a list called arrow hits X. So we're going to go through that. We're going to have basically each of these clones check their own X position against the list. So against every item on the list. So we've got to repeat this the length of times that matches the number of people on the list here, the number of entries on the list here. So we're going to go repeat length of arrow hits X. All right, so so each clone is going to go through this list of arrow hits and compare its X position to these arrow hit X positions here. So let's grab an if here. This isn't an if else, is it? No. So let's grab an if statement here, and we'll say if, and I need an and as well. So let's pop an and statement in there. So if I'm touching an arrow, that's the first step. So if my bad guy is touching an arrow, my zombie in this case, and I'm within a certain range of the X coordinate in that list. So I'm going to grab my own X position of my zombie here. So let's go X position minus. So what I'm trying to figure out here is how far away I am from the first item on the list. So my X position, compare it to the first X position on the arrow hits X list. So we're going to go item. We'll grab that from our list menu here. Item of arrow hits X. So which item? Well, the first item. So we're going to grab that temp variable, which is now set for 1. So this is going to look at item 1 of arrow hits X, and that will return an X value, in this case 219. And it's going to compare that number to my X position and see how far apart they are from each other. So if that item is less, so first of all, we could be to the left or to the right of that arrow hits X position. It doesn't matter which, and that's why we're going to take the absolute value of that. So 10 minus 5 is 5, but 5 minus 10 is negative 5. It doesn't matter. Both of them are 5 apart from each other. So if we grab the absolute value of that number, the absolute value of that distance, so even if it's a negative number, that'll turn into a positive number. So if this number, the distance between the list and my current X position, is less than, let's grab a less than and pop all of this into there. If it's less than 32, you'll remember that our grid is 32, so if it's less than 1 grid square away, so if, and let's pop that into here. So if I'm touching an arrow and I'm less than 1 grid square away from the X position that got noted in my list here, then we're going to delete the clone, but first we're going to remove this item from the list so that another guy can't get hit by the same arrow. So let's walk through this here. We're going to delete the first item on the list. So let's go back to our list variables. We're going to go delete item temp, which in this case is 1, but next time around the loop it'll be 2. Okay, so we've deleted, let's say it's the first item on the list here. Later on in our loop here, we're going to advance this temp variable to 2 to check the second item on the list. But we've got a problem here, which is that when we deleted item 1 from the list, item 2 became item 1, right? Because the list always moves itself upwards. When there's a blank item on it, it moves everything up 1 to fill the new spot on the list. So we're going to end up skipping an item on our list here as we're checking through it if we're not careful. So that's why at this point we have to change that temp variable. If we deleted an item, we have to change temp by -1 so that we go back and check that same slot again the next time around, because there's suddenly going to be a new item in there that we have to check against. All right, now we're going to damage our character here. All our characters have hit points. It's a local variable. So let's go change health points. So every zombie has their own health points. It's 2 health points for zombies. So we're going to take 1 hit point away for each zombie, for each arrow, which means it's going to take 2 shots to kill it. All right. Now, until the zombie's dead, after the zombie's been injured, he's going to turn red for a second to give you some feedback that he's been hit. And he's going to stay red for 8 frames of animation. So we have another variable here. Let's set a variable. And that variable is called red frames left. We're going to set that to 8. And so later on in the script here, we're going to be changing the zombie's color and not changing it back again until this red frames left variable gets back down to 0. Okay, let's put an if statement down below here. Actually, it's an if with an if else inside it. All right, so we're going to say if health points are greater than 0, let's grab a greater than sign. So if the zombie is still alive, if it has more than 0 health points, and it's just gotten hit, because we know that it's gotten hit because it's inside this if statement, then we're going to have it play a zombie injury sound. There's 2 different sounds here. We're just going to have our zombie randomly pick between the 2 sounds with an if-else statement. So we're going to pick a random number between 1 and 2. Just flip a coin, basically. So if pick random from 1 to 2 equals 1, then we're going to play the sound called hurt. Let me play that for you right now. So this is hurt, and this is hurt 2. Just a slightly different sound, just to mix things up. There we go, we got 2 different hurt sounds here. So let's play the first sound in the first slot and the second sound in the second slot. So the sound is hurt here and hurt 2 here. All right, now once we get out of this loop, I'm going to measure 2 slots down from here. So there's actually 4 orange rows here. Halfway between them, this is where I'm going to change my temp variable back. We're going to come around that loop again, and if we haven't been injured, we'll check the second spot on the list here. So let's go change variable right in this spot here. Change temp by 1. All right, so once it's gone through this entire list here and checked every item on the list, then it's going to change red frames left by -1. So basically inside here, because we checked the run without screen refresh, it's basically zipping through this the exact number of times that it needs to for the number of characters that have been injured on the screen, basically. If it gets to the point where it actually finds a guy whose X position matches and is touching an arrow, it's going to injure that specific guy here and then remove itself from the list so that the next guy who runs this check for damage isn't going to see it. Then he's going to turn red and stay that way basically until he dies or until that timer runs out. So we're going to change red frames left by -1 here, and we're going to add another if else here. And here's where we're actually going to control that color effect. So let's grab a less than sign. So what we're going to say here is if that red frames left has been brought down below 1 again, if it's back to 0. So let's go variables red frames left. So if it's less than 1, which is the way it's normally going to be unless we're injured, then we're going to set color effect to 0, which means do nothing interesting with the color effect. But if our red frames is higher, any number higher than that, we're going to change it by 125. Whoops. There we go. So it's going to make that guy red for a little bit. All right, so it's checking through every item on that list to see if it matches up, and if it does, it's going to delete that guy. Let's give this a try here. So let's place an archer. Activate our mode here, and let's try firing once at this guy. Missed. I'm a horrible shot. There we go. He turns red. He makes an injured sound. And things kind of break down here because we're not done our code yet. But so our guys are getting injured, but we don't have any. We haven't checked to see if they're dead yet. We don't have any code for them dying yet, and it looks like our arrow isn't resetting itself after that happens. So there's a couple more things we have to do here. We'll get right on that. Okay, you probably noticed a minute ago that as soon as I hit my first zombie, my bow disappeared from my hands and I was no longer able to shoot. That was because of a little glitch that I made here under check for damage. When I went delete temp I had initially put archer indexes here. So that's actually deleting the entry for that archer, which we weren't supposed to do. We were supposed to delete arrow hits X. So that's going to delete that arrow hit from the list, but we'll still be able to continue shooting arrows there. That was a little minor error, and that should be working fine now. Let's go back and finish the death animations for our zombies, and then we can give it one more test here. So I've got defined block here that says die, and that will be checking for, basically, we're looking at hit points in here in the main script. If our health points are less than 1, then we're going to run this death script after the check for damage. So if our zombie is in fact dead, we just have to do something with the animation here. So the first thing we want to do is, where is that? Looking for the death script. Here it is. All right, so we're going to make our guy turn red again if he's dead. So let's go to looks, set color effect to 125, which will give him a bit of a red color. Now we need him to start spinning. So right now his rotation style is locked so that he can't spin. So we're going to go to set rotation style and change it to all around, and that will let him spin. We're going to tell him to point in direction 90, which is the directly upright position. And then we're going to start spinning him to the side as he falls. But first we want to play a sound effect. So we have a sound effect here called death. And we'll play that. And then we just wanted to rotate over a little bit at a time. So we're going to do a repeat 15 here. And each time we do that, we're going to turn 6 degrees. So 6 times 15 by my math is 90, which should turn him sideways basically. So let's go to motion, turn him 6 degrees to the right. And as he's turning, we're going to make him fade a little bit. So we'll go to our looks commands here. We're going to change ghost effect by 2 every time. So he's going to be a little bit transparent while he's falling. And then we're going to finish making him transparent with another repeat loop. Once he hits the ground, we're going to repeat 35 times. And we're going to change that ghost effect by 2 again. So this will take him for the first 30% to transparency, and the remaining 70% to get 100 transparency will happen after he lands on the ground. And then once that's all done, we can delete the clone and get rid of the zombie. So let's have a look at that now. Green flag on my one piece of dirt here. Put down a little tower for our guy. Put a fellow down. Get to shoot mode here. Fire once. He's injured. You saw him turn red, but he has a hit point left. One more, and there he goes. He falls down and dies. Excellent. All right, now we're doing some damage here. Now the game's getting fun. Now you'll notice that we cannot shoot our creepers. We don't have our code done for them yet. And we haven't even started talking about endermen yet. We're going to do that next week. But let's quickly get some code in there for our creepers so we can shoot them as well. Okay, so getting the creepers working isn't going to be all that difficult. It's exactly the same code as in the zombie. If you look over in the creeper sprite, we have a blank check for damage here and a blank die block here as well. So we're just going to grab the contents of both those blocks from the zombie. Don't drag over the custom sprite, just all the code that's underneath it. So I'm going to grab check for damage here, grab it from the block down below it, and drag that over to the zombie until it wiggles, and I'm going to let go. Let's go back to the zombie. Here's my blocks. Plug that into check for damage. Let's do the same thing to die here. Well, let's go to the die code. Grab the block down. Oh, where'd my die go? There it is. Grab the block down below it, drag it over to your creeper, and then attach that loose code to the red die block. And now let's wait for a bad guy to appear here. We'll place an archer down, get to shoot mode here. We'll shoot him And we've got you can see that only one of these two guys is being hurt. So, Creeper's already taken one hit. Creeper takes another hit, and he dies. Beautiful. So we're defending ourselves quite nicely here. You see these guys both occupy the same space, but only one of them is getting hit. Beautiful. That's exactly what we want here. All right, it's a bloodbath over here in Minecraft land. Perfect. All right. So the zombies can, we can kill zombies and creepers now, but they can't kill us. So let's return the favor. And then we'll wrap up for today. So I'm going to go back to my archer character. And I'm looking for a when I started the clone block in here. And right now there's very little in there. Where did that go? Let's get rid of this. I had temporarily added a block here that gave me money every time I hit the space key. That's no good. That's cheating. So I got rid of that. Here's my when I started the clone. Right now, all that happens when we started the clone is we switch to our archer costume. We're going to add a few more blocks here that are going to make our guys vulnerable to enemies. So up here under the green flag code, when we created a new archer, we added an item to this archer indexes list, number 1, for example. But that list needs to match up with a variable on the individual clone. So every time we create a clone here, when I started a clone, we're going to set a variable called my archer index. That's going to be my unique ID number for that character that's being created. We're going to set that to new archer index, which is the number that's been added to this list. So each time we add an item to this list, we're going to give him, under his my archer index variable, a number that matches up with him. And that's part of the process of how we're going to be killing these guys off. Okay, now we have to do a wait 0 seconds. Again, we're giving time for other processes to happen elsewhere on the screen. Often you don't know you need this until stuff starts to fall apart in your program, and then you realize that something else is working faster than your clone making here, and you have to rearrange things so that one thing happens before another thing happens. Okay, let's go add a forever here. We're going to add a couple of if statements here. So let's do the first if statement. If shooting mode active is equal to 1. So let's go, and we'll grab an equal sign here. So if shoot mode active is equal to 1, which means we're firing, then let's point towards mouse pointer. So that's just a little bit of housekeeping here that was stopping these guys from facing in the right direction. And you might have noticed that earlier, that when we were creating bad guys and got them, archers, and got them into shooting mode here, they were not facing in the same direction they were shooting. So that's been repaired now. Now we need to make ourselves vulnerable to these bad guys when we're touching them. So that's the next thing we're going to do here, another if statement. And I'm going to say if, and I need a couple of or statements here. We're going to be touching all the potential bad guys here. So if I'm touching a zombie or a creeper or an enderman, let's put a couple of these guys in here, creeper, enderman, or zombie. There he is. We're at the top of the list. So if we're touching a bad guy, we need to delete our character from the list. So we're going to go delete. This is from our list variables. Here's delete from archer indexes. But we're not deleting number 1. We're deleting my archer index. So let's grab a variable here that says my archer index. So this is the number that corresponds to my character. And we're going to delete the item number. So we're going to grab an object here that says item number. So we're going to delete item, if this was our first archer, item 1 in archer indexes, which also happens to be 1. So we're going to delete that 1 from the list. Or if it's item 2, it's going to be delete archer number 2 from the list, basically. So that's getting these guys off the list, and there's another spot elsewhere where we're going to delete that clone. And that is with a custom block here called die. I don't think we've made that custom block yet, so let's go ahead and do that right now. We'll go create a custom block here. We'll call it die. And what's in die here? Well, first of all, we're going to put the block right down below here. And so if we die, we're going to change our character's color. Let's go to our looks command here. We'll go set color effect to 170, which I believe is going to make it another red, another shade of red, but let's see that in just a second. We're going to set rotation style to all around. Again, just like we did with our zombies, we're going to let this guy fall over. So let's go to our motion blocks, set rotation style to all around. We're going to point him, make sure he's pointed in direction 90, so he's upright. And we're actually grabbing all the code from the death animation in the zombie. So I'm just going to grab the next couple of items, just those repeat loops from the die block inside the zombie. Yeah, here it is. I'm going to grab these 2 repeat loops. They both work exactly the same way in the archer. Just save myself a little bit of coding here. So it's repeat 15 times, turn 6 degrees, and then repeat 35 times, change ghost effect by 2, and then delete this clone. Okay, I noticed one little bug in the code here, and under when I start as a clone, we're in the archer here. After we switch costume to archer, I set my archer index to my archer index. I don't know if I described it to you this way, but this is supposed to actually say new archer index here. So we're adding the new number to and adding it to my archer so that the archer would actually have the proper number. If this isn't fixed, then your death animations aren't going to work properly. Let's give this a try now and see if everything's working properly. I'm just going to place a archer down here and see what happens. We'll wait for somebody to spawn on the left here to kill me. I'm actually going to create more than one. Oh, there we go. So when these guys touch me, you'll see I fall down and my bow disappears as well. Let's gather a little bit more gold here. Actually, I'm going to restart the game. I'm going to gather a little bit more gold so I can place 2 archers here. And you can see that our list system is working the way that it's supposed to here. We'll have 1 archer, another archer. Both of them can fire. And when one of them gets touched, only he will die. That's something that we'll have to be sure about here. Yeah, there we go. The one guy's dead here. And so if we look at our list variables, you'll see that when we have multiple guys being created, so I'm going to create, let's try this one more time. I'm going to get some money here. So I'm going to create an archer here. And I'll create a second archer, archer number 2 here. And you'll see when this guy gets killed, this is number 2, he's going to disappear from the list first because of his ID number. And then number 1 will get killed from the list here. Perfect. Okay, this is all working beautifully now. So that's about enough for today. We got quite a bit done. So we're now shooting our arrows. We're killing monsters and monsters are killing us. We're going to continue this next week with part 5. And and we're going to get the endermen going, and we've got a few other things to clean up with this main level here. We have to add the end portal that will take us to the end scene. And I don't think we're going to get done in part 4. This will probably extend to a part 5. Sorry, this was part 4, right? So I think this might even extend to part 6 here. So next episode for sure we'll get the endermen and the end portal done, and that will bring us across to the end, the final boss battle in the game. And when we're done that, we'll move on to the Ender Dragon and the final climactic conclusion of our game. So I hope you're enjoying this tutorial. Please, if you have any thoughts or comments, you can write them down below or drop me an email at info@chromeworks.ca. Hope you guys had fun with this, and please like and subscribe. I'll see you next time.